A 10-year-old tomato seed sat forgotten in a kitchen drawer. Dry, shriveled, by every measure, dead. Then someone dropped it into a simple solution that costs less than 3. 48 hours later, a bright white root pushed through the shell. That solution is sitting in almost every bathroom medicine cabinet right now. And most gardeners have no idea what it can do. This is the story of hydrogen peroxide and seeds, a connection that reaches all the way back to thunderstorms, ancient survival chemistry, and one of the most overlooked germination secrets in modern gardening. Here is what the expensive seed catalogs never mention. Nature already invented the perfect germination trigger. It falls from the sky every spring, and a $3 bottle from the pharmacy is the closest thing to bottling that storm. But before reaching for that brown bottle, it helps to understand exactly what is happening inside a seed. Because the science behind this trick is what makes it so remarkably effective. Most people look at a seed and see something inert, a tiny pebble, a speck. That is a mistake. A seed is a living organism in suspended animation. Its heartbeat is slowed to almost nothing, but the machinery of life is intact, coiled tight, waiting. Evolution engineered seeds to survive the worst that nature can throw at them. Scorching desert heat, months locked in frozen ground, even a trip through the digestive system of a bird. If a seed sprouted the instant it hit soil, the first frost or dry spell would kill the seedling outright. So nature built 2 layers of defense. The first is physical. The seed coat, called the testa, is a shell of tough, sometimes woody tissue. In many species, it is completely waterproof. Water simply cannot reach the embryo inside. The second defense is chemical. A hormone called abscisic acid, or ABA, circulates inside the seed like a constant whisper. Not yet, not yet, not safe. Together, these 2 barriers create dormancy. The seed holds its breath. It can hold it for years, sometimes decades. Dormancy is not death. Every bit of potential is still locked inside. The seed just needs one very specific signal to finally let go. And that signal has everything to do with a thunderstorm. Here is something most gardeners never hear about. When lightning rips through the atmosphere, it forces oxygen and moisture to combine in a very specific way. The result is a trace compound that mixes into the falling rain, hydrogen peroxide. The chemical formula is simple, H2O2. That is just water with 1 extra oxygen atom clinging to it through an unstable bond. When spring rain carries even tiny amounts of this molecule into the soil, it sends a chemical wake-up call to every dormant seed it touches. A standard brown bottle of 3% hydrogen peroxide from any pharmacy costs $2 or $3. That bottle is, in a very real sense, a concentrated spring thunderstorm. And here is the part that surprises people. This is not some harsh lab chemical being forced onto a seed. Hydrogen peroxide is the exact molecular signal that seeds evolved to respond to over millions of years. When it breaks down, it leaves behind nothing but water and pure oxygen. No residue, no toxicity. Just the 2 things a seed needs most. So what actually happens when that molecule meets a stubborn seed coat? This is where gardeners make one of the most common mistakes, and hardly anyone talks about it. Seeds with hard coats, sweet peas, beans, nasturtiums, even wild desert shrubs, resist water like a sealed vault. The standard advice is to nick them with a knife or scrape them with sandpaper. That process is called mechanical scarification, and it works. But one slip damages the embryo. The seed never recovers. Hydrogen peroxide offers something far more elegant. It acts as a chemical scarifier. The oxidative power of that extra oxygen atom goes to work on the lignified woody fibers of the seed coat, gently, evenly. No blade, no guesswork. Within minutes, the waterproof seal softens and moisture begins flooding into the center of the seed. Think about the difference. One method forces the shell open with a blade. The other lets oxygen dissolve the barrier on its own terms. The shell is not smashed, it surrenders. And once water reaches the embryo, something dramatic starts happening inside. Something that explains why plain water soaks so often fail. Germination is not a gentle process. It is one of the most energy-intensive events in a plant's entire life. To push a root downward against compacted soil and a shoot upward against gravity, a seed needs a massive burst of cellular energy. And to produce that energy, it must breathe. It absolutely requires oxygen. Here is the problem almost nobody warns gardeners about. When seeds are soaked in plain tap water, they start consuming dissolved oxygen immediately. Within hours, that oxygen is gone. The water becomes stagnant. The seeds suffocate. Suffocating seeds do not just fail to sprout. They ferment. They produce ethanol internally. They rot from the inside out. That is why so many overnight water soaks end with slimy, dead seeds by morning. A hydrogen peroxide soak changes the equation entirely. As the H2O2 penetrates the seed and breaks down, it releases a steady stream of pure oxygen directly where the embryo needs it most. That oxygen surge triggers a cascade of hormonal shifts. Levels of abscisic acid, the sleep hormone, drop sharply. Production of gibberellic acid, the grow hormone, ramps up fast. Enzymes called alpha amylase and proteases flood the seed's interior, converting stored starch into usable sugar, and breaking down proteins to build new cells. Research on mung beans documented a massive spike in these enzymes after hydrogen peroxide treatment. The practical result? Seeds that normally take 2 weeks to show a root tip can crack open in 24 to 48 hours. Plain water soak, 2 weeks. Hydrogen peroxide soak, 2 days. Same seed, but germination speed means nothing if the seedling dies the next morning. And that brings up a hidden threat that catches even experienced gardeners off guard. Every handful of garden soil is crawling with fungal spores, bacteria, and mold. Most of it is harmless. Some of it is waiting for exactly the kind of meal a germinating seed provides. The disease is called damping off. A seedling pushes through the soil looking perfectly healthy. The next morning, it is collapsed at the base, rotted through by fungal infection. Gone overnight. Damping off is one of the most heartbreaking losses in gardening, because it strikes after the hardest part is already done. Hydrogen peroxide is a powerful broad-spectrum antimicrobial. When seeds soak in the solution, the bubbling oxidative action destroys mold spores, bacterial pathogens, and fungal invaders clinging to the seed coat. In scientific trials with zinnia seeds, notoriously vulnerable to a deadly fungus called Alternaria zinniae, a hydrogen peroxide soak slashed the infection rate dramatically and saved seeds that would otherwise have been lost. The seed emerges not only faster, but cleaner, sanitized, ready to face the soil without carrying its own enemies along for the ride. This matters especially for home-saved seeds, seeds collected from last year's garden that may carry whatever pathogens were in that soil. Now, speaking of saved seeds, here is where this story takes its most remarkable turn. Almost every gardener has a drawer, a shoebox, or a jar somewhere full of old seed packets. 5 years old, 10 years, sometimes 20. Over time, seeds deteriorate, cell membranes degrade, energy reserves dwindle. DNA accumulates oxidative damage from the simple passage of time. Plant a 10-year-old seed in standard soil, and the odds of germination are close to 0. Most people throw them away without a second thought. But researchers found something that feels almost impossible. In university studies, cannabis sativa seeds over 5 years old, seeds with a dismal 10% germination rate in plain water, were soaked in a 1% hydrogen peroxide solution. The controlled oxygen surge neutralized accumulated aging damage and triggered internal repair mechanisms. The germination rate jumped from 10% to 50%. In a separate study with severely deteriorated sweet corn seeds, hydrogen peroxide repaired damaged cell membranes and boosted germination from 48% to nearly 70%. Seeds that had been written off, seeds everyone assumed were dead, they cracked open and sent out strong white roots. Imagine finding a seed packet saved from a grandmother's garden 15 years ago, a favorite heirloom tomato, a zinnia she grew every summer. Drop those seeds into a $3 solution, and there is a real documented chance they come back to life. That is not wishful thinking. That is published science. And the benefits do not stop at germination. What hydrogen peroxide does afterward is just as remarkable. In agricultural research on sorghum, a staple grain grown in some of the driest climates on Earth, scientists discovered something unexpected. When drought conditions hit, seeds that had been pre-treated with hydrogen peroxide survived and grew far better than untreated seeds. The explanation comes down to a principle called hormesis. The brief controlled stress of the hydrogen peroxide exposure triggered the seed to build up its own internal defense systems, protective proteins, and antioxidant enzymes like superoxide, dismutase, and catalase. The seed was essentially armored from the inside before it ever faced the real challenge. For home gardeners, this means hydrogen peroxide treatment is not just a germination trick. It produces seedlings that are measurably tougher when they hit unpredictable spring weather, a late frost, or a dry spell. Stronger roots, better stress tolerance, a head start that lasts well beyond the first days in the soil. Everything needed is probably already in the house. Start with a standard brown bottle of 3% hydrogen peroxide from any pharmacy or grocery store, not the industrial 35% concentration. That will burn seeds on contact. The everyday 3% bottle is exactly right. Mix 1 part hydrogen peroxide with 2 parts clean, room temperature water. That creates a 1% working solution. 1 tablespoon of peroxide to 2 tablespoons of water, or 1 cup to 2 cups for a larger batch. Distilled or filtered water works best. Heavy chlorine in some tap water can interfere with the reaction. Place the seeds in a clean glass or ceramic bowl. Pour the solution over them until fully submerged. Soak times depend on the seed. Small, delicate seeds, lettuce, carrots, basil, need only 15 to 30 minutes. Average vegetable seeds, tomatoes, peppers, cucumbers, benefit from about 30 minutes. Tough, hard-coated seeds, beans, peas, squash, or very old rescued seeds can soak for 12 to 24 hours. Set the bowl in a dark, warm spot like a kitchen cupboard. Light breaks down peroxide too quickly. For exceptionally old or weakened seeds, a small pinch of table sugar in the solution gives the exhausted embryo an instant energy source alongside the oxygen. Watch for tiny effervescent bubbles forming on the seed surface. That is pure oxygen being released, fighting off pathogens and shaking the embryo awake. After soaking, drain the liquid and rinse the seeds thoroughly under clean running water. From here, 2 options. Plant directly into moist potting soil, knowing the seeds are primed and ready. Or, to watch the magic happen in real time, lay the rinsed seeds on a damp paper towel, fold it over, slip it into a Ziploc bag, and set it somewhere warm. Check every day. Expect to see strong white roots emerging in 1 to 2 days, a process that normally takes weeks. A $3 bottle, a kitchen bowl, 10 minutes of setup. That is all it takes to replicate what a spring thunderstorm does for every seed in the wild. Soften the shell, flood the embryo with oxygen, destroy invisible pathogens, and wake up life that has been sleeping for years. The toughest seed coats dissolve without a blade. Seeds written off as dead push out roots in 48 hours. Seedlings emerge cleaner, faster, and measurably stronger. Somewhere in a drawer or a jar, there are seeds waiting. Old packets, heirloom varieties, seeds saved from a garden that meant something to someone. They are not dead, they are dormant. And now, the signal to wake them up costs less than a cup of coffee. If this story changed the way you look at those forgotten packets in your drawer, please subscribe and like the video. We are uncovering the natural secrets that have been hidden in plain sight. Let's grow the future together. Our next gardening treasure will be revealed very soon.